Welcome back to the channel. Today we will be focusing on the lube oil cooler temperature control valve. The lifeblood of any ship's main engine is its lube oil, and keeping that oil within a very narrow temperature range is critical for machine health and efficiency. Too hot and the oil thins out, losing its protective film strength, leading to rapid wear on bearings. Too cold and it becomes thick and viscous, making it hard to pump and potentially causing damaging deposits. The component responsible for this precise thermal balancing act is the lube oil cooler temperature control valve, often just called the thermostatic valve or three-way valve. This valve is the brain that regulates how much cooling the oil receives. It's an automatic self-regulating valve, meaning it does its job without continuous manual intervention from the engineer, though a manual bypass is always available. The valve's operation is based on a simple yet ingenious principle: thermal expansion. Inside the valve, there's a sensing element or wax thermostatic element. This element contains a special wax compound that is highly sensitive to temperature changes. When the lube oil temperature changes, this wax either expands or contracts significantly. Here's how the three-way valve works. It has three main ports. One port receives the hot lube oil coming directly from the engine. A second port directs the oil to the cooler, and the third port is the bypass port, which sends oil around the cooler and back to the engine sump. The internal mechanism, driven by the expanding and contracting wax, is a movable piston or spool that shifts position to modulate the flow between the cooler and the bypass lines. If the main engine lube oil temperature is too low, say during startup or low-load operation, the wax element contracts. This shifts the piston to primarily block the flow to the cooler and open the bypass line. Most of the oil recirculates directly back to the engine, allowing it to rapidly heat up to its optimal running temperature. Conversely, if the lube oil temperature rises above its set point, say 55 degrees Celsius, the wax expands powerfully. This expansion pushes the piston, gradually closing the bypass line and opening the line to the cooler. The increased flow to the cooler allows more heat to be removed by the cooling medium, which is typically seawater or low-temperature fresh water. The valve is constantly smoothly oscillating between these two extremes. Mixing cooled oil with bypassed oil in exactly the right proportions to ensure the combined stream maintains the desired stable temperature before it returns to lubricate the main engine's crucial components. If you found this video helpful, please give us a thumbs up, hit the notification bell, comment, like, share, and subscribe for more insights. Thank you.